So in today's class, we are going to study about relational algebra, right? So relational algebra is a procedural query language. It consists of a set of operations that take one or two relations as an input and produces a new relation as a output, right? So the relational model is based on a relational algebra, right? So whatever we are going to study, a relational model, the popular model in commercial database management system, it's based on relational algebra. So relational algebra is a procedural query language. So it consists of a set of operators that take one or two relations as a input and produces a new relation as a output, right? So we have some operators that are possible with a relational algebra. We'll study about select operator, project operator, union operator, set difference operator, Cartesian product operator, and rename operator in today's class, right? So this operators can be this operators, relational algebra operators, are the basics of manipulating the data that is being present in the relational model, right? So let us look into the first operator, right? So the first operator is going to be a select operator, which is used to select tuples or records or rows in a relation, right? So assume you have a relation R, right? So the select operator denoted by the symbol sigma, it's used to select tuples or records from a relation, right? So it is denoted by the Greek symbol sigma, right? So sigma relation. Yes. So you are going. It is going to select all the attributes. So it is going to select all the records or tuples for which attributes values A is equal to B, and the attribute value D is going to be greater than 5, right? So this relational algebra operator, it means that you are going to use select statement. Sigma is used to represent select operator. R is the relation on which you are going to apply the select operator. So here select star from relation R, where A is equal to B, right? So where the attribute values of A and B are going to be the same, and the attribute value of D is going to be greater than 5, right? So A is, so in this relation R, A is equal to B in so A is equal to B in tuples first, third, and fourth tuple, right? So the value of A and B are going to be same in first record, third record, and fourth record, and right, the value of D is going to be greater than 5 in only first and last tuple, right? So it is used to display the tuples that satisfy the following constraints. So you are going to select tuples from relation R using this Greek operator sigma, where the values of the attributes A is equal to B and the value of the attribute D is going to be greater than 5, right? So this is the output of the relational operator sigma, right? So the next operator is going to be project operator, right? So select operator is used to select records or tuples in a relation, whereas project operator, it's used to filter out a few columns in a relation, right? So for example, I have 3 columns and I want to display only 2 columns in a relation, right? Then I can go for this project operator, right? So the project operation is given by the Greek symbol pi, right? So you have your relation R with 4 tuples with the values alpha 10, 1, alpha 21, beta 31, beta 42, right? So you have 3 attributes A, B, and C, and I want to display only 2 attributes in a relation, right? So I want to display only right. So I have a student relation. I want to display only a student ID and name, right? So I will write the query like select student ID comma student underscore name from student, right? So I need not display all the details about the student. I need to filter out only two attributes and display. Then I need to go for this project operator, right? So mathematically in relational algebra, this pi operator is used to filter out the attributes that are present in a relation. So here it is used to display only the attributes A and C present in a relation R, right? So the output of pi operator, project operator pi of A comma C R is given by it will display, it will filter out the attributes and it will display only the attribute values for the attributes A and C respectively, right? So this is how the project operator works, right? So so select operator is used to select a record or a tuple from a relation. It is denoted by the sigma symbol, Greek symbol sigma, right? So again, what you need to know about select operator is that you can use the various relational operators equal to, right, greater than. So you can use the various relational operators in select operator, and you can also use the different logical operators like logical or and not operator in select operation, right? So select operator is used to select records or rows or tuples in a relation, whereas the project operator is used to uh, it is used to project, or it is used to filter out only few attributes in a relation. To display only that selected attributes in a relation, we go for this project operation, right? So next we have this union operation. So the union operation it's a binary operator, right? So binary operator in the sense that it takes input as two relations and it gives the union of the tuples that are present in both the relation, right? So for example, you have a relation R with the attributes A and B with the values alpha 1, alpha 2, beta 1, and you have a relation S with again attributes A and B with the values of the attributes alpha 2, beta 3 respectively, right? So or union, yes, right? So union is a binary operator. It takes two relations as input and it produces the union of the tuples in the participating relation, right? So you have alpha 1, alpha 2, beta 1, beta 3, right? So it finds the union of all the tuples in the participating relation. We use this set union operator, right? So we also have set difference operator, which is again a binary operator, which takes two relations as input and it returns the tuples that are present in the relation R but not present in the relation S, right? So so the set difference operator, it's a binary operator. It takes two relations R and S as input and it produces output relation, right? So the output contains the tuples that are present in R but that are not present in the S relation, right? So R minus S will give the values alpha 1 and beta 1, right? So these are the two unique tuples that are present in the relation R but not present in the relation S, right? So this is about working with set difference operator, right? So the next set operator is going to be set intersection operator, right? So set intersection operator, again it's denoted by intersection symbol, right? So it again it's a binary operator. It takes two relations as input, right? So two input relations are given as input, and it returns the tuples that are present in both the relations R and S, right? So the tuple that is common to both the relation R and S is going to be alpha 2, right? So the set intersection operator, it returns the tuples or records that are common to both the relations R and S, right? So like we have also discussed about how to work with union operators, set operators in SQL, right? So that's the basics. So relational algebra is the basics for working with the different types of SQL operators, right? So relational algebra is the basic for SQL language, structured query language, right? So whatever we have discussed, select operator to select records or tuples in a relation, right? Project operator to filter out a few attributes in a relation, to display the to selectively display few attribute values in a relation, right? We go for a project operator. So we discussed about the different set operators. So you have a set union operation, right? Set union operation is going to be a binary operator. It takes two relations as input, and it produces the union of all the tuples in both the participating relations, right? So it returns the union of the tuples in both the relations R and S. And set intersection operation, again it's a binary operator. It takes two relations as input, and it returns the tuple that is common in both the relations R and S, right? Then we have this Cartesian product relation, Cartesian product operator, right? So you would have, so we studied about the Cartesian product operator in SQL also, right? So we have different types of join: left join, right join, inner join, right, outer join. So you also have the Cartesian join. So it allows to combine the information from any two relations, right? So Cartesian join or Cartesian product operation, it denoted by the symbol cross, right? So it's denoted by the cross symbol. It allows us to combine information from any two relations, right? So the Cartesian product of the relations R1, R and S is written by R cross S, right? So it gives the different possible, all the possible combinations of the relations R and S, right? So have two attributes in relation R, A and B, and you have three attributes in relation S, C, D, and E respectively, right? So the Cartesian join of the relation R and S is given by right, all the possible combinations of the relation R and S. So it's going to be alpha 1, alpha 10A, alpha 1, beta 10A, alpha 1, beta 20B, alpha 1, gamma 10B, and beta 2, alpha 10A, beta 2, beta 10A, beta 2, beta 20B, beta 2, gamma 10B, right? So it gives the different combinations of the tuples in the participating relations, right? So if you assume that there are n1 tuples in relation R, and you have n2 tuples in relation S, then there are n1 cross n2 way of possible combinations, right? So you have two tuples in relation R, and you have four tuples in relation S. So whenever you perform Cartesian product operation, 2 cross 4, so you have 8 possible combinations of the tuples from the participating relations, right? So this is how we are going to join two relations using a Cartesian product, right? So it is denoted by the cross symbol, right? Right. Cartesian product naming issues, right? So in the first case, we have the attribute names are going to be different in the participating relations, right? You have A, B for relation R. So you have a relation R with the attributes A and B respectively, and the relation S with attributes C, D, and E respectively. Whereas if you are going to have the same name, right, in both the participating relations, right? So relation R contains the attributes A and B respectively, and the relation S contains the attributes B, D, and E respectively, right? So whenever you are going to do Cartesian product, you can identify a particular attribute by its relation name, right? So it will be R dot B, and the B attribute in the relation S is given by S dot B, and so that you will be able to resolve the name conflict while you are performing a Cartesian product operation, right? So this is about working with Cartesian product operation, right? So next the operator is going to be relational operator is sorry the next relational algebra operator is going to be a row operator, right? So the row operator it allows us to refer to a relation by more than one name, right? So for example we are going to perform here in this example, we are going to temporarily rename a relation R as S, and you are going to perform the Cartesian product of the relation R and S respectively, right? So the renaming of a table or right, it is done by using this row operator, right? So the Greek symbol rho is used to represent renaming of a table. So it allows us to refer to a relation by more than one name, right? So we are going to refer to the relation by more than one name. So we are going to have this row operator. So row of X E, it returns the expression E under the name X, right? So row of Ex means row of Ex means it returns the expression under the name X. Similarly, row of RS means it is going to rename the relation R and return the relation as S, and you are going to perform Cartesian product of the relation R and S respectively, right? So you are going to temporarily rename the relation R into S using the row operator, and you are going to perform the Cartesian product of R and S. So basically it's performing a product of Cartesian product of R to itself. So the different values in the relation are going to be alpha 1, alpha 1, alpha 1, beta 2, beta 2, alpha 1, beta 2, beta 2, right? So this is about working with row operator or renaming operator in relational algebra, right? Right. So let me summarize first whatever we have done, then we'll come back to, right. So the first operator that we discussed in relational algebra is going to be sigma operator. So sigma is used for selection of records or tuples in a relation. It is denoted by the Greek symbol sigma, right? So for example, we want to rewrite an SQL query by using a relational algebra, right? So select star from instructor where salary is going to be greater than 85,000, right? So this select operator, it returns all the rows of the input relation that satisfy the predicate. So right, so selection operation is used to return the rows or tuples or records in a relation. So here the relation name is going to be instructor, right? So you are going to select all the rows from the instructor relation for the attribute value salary is going to be greater than 85,000. So it will return the details of all the instructors whose salary is going to be greater than 85,000. And project operation, right? Projection, it outputs specific attributes from all rows of the input relations, right? To filter out or to output only specified attributes from all the rows of the input relation, we go for the project operation. So for example, I want to display only the ID and salary of an instructor, right? So I'm not interested in name, age, date of joining, and so on. So we want to display only we are going to take instructor relation as an input, and to display only the attribute details like ID and salary, we go for this project operator. So it's denoted by the symbol pi, right? So pi ID comma salary, the relation is going to be instructor. So it outputs specified attributes from all the rows of the input relations, right? So it removes duplicate tuples from the output. And we have discussed about this Cartesian product star cross. So it's denoted by cross symbol. So instructor cross department. So it outputs a pair of rows from the two input relations that have the same value on all the attributes that have the same name, right? So we know how to represent a Cartesian product. So you have two relations R and S, right? So let us assume that there are n1 tuples in R1 and n2 tuples in the relation S, right? The Cartesian product will give the output of n1 cross n2. It will return the Cartesian product of the participating relations, right? So we have discussed about this set operators, set union, right? So you are going to select, right? You are going to output the union of tuples from the two input relations, right? So project name from instructor, union project name from student. So the union operator will return the union of the tuples from the input relations, and set difference operator, it will return the names of the instructors that are unique and that are not present in the student relation, right? So the last operator that we'll be discussing is going to be a natural join operator. So it outputs pair of records from the two input relations that have same value on all the attributes that have the same name, right? So we'll discuss about this natural join, and with that it completes end of